Next, after the two halves are put together and the water wheel is one solid piece, then we put on get ready to suspend it. I got a couple of pieces of pipe and some closet flanges or floor flanges or whatever you call them, plumbing fittings, 3/4 inch stuff from a local hardware store. So next, take the tape measure and measure the exact center in at least 2 directions and mark it, which you probably already have that marked, but check it both ways and make an exact center point mark like the one I have here to use it to align the plumbing flange. So once you've got the center marked, got the 3/4 galvanized floor flange, which is like a plumbing fitting, and you're going to align it so that it is exactly centered on your center mark, and screw it in with the 4 screws, and those will go through the spoke and of course into the key, the block on the other side, attaching it to the hub to carry the weight. So once we got the wheel itself constructed and the flange is put on and the 3/4 inch pipe nipples in for axle, the spinning axis. Of course, we can't wait to see our water wheel go, so if you've got a spot for it, you can, set it up as your garden ornament. But if you don't have a place for it yet, of course you want to test it and see it spin, so we're going to put together a simple base to test it. If you're using scraps from a deck project, as we are, of course I got more 2x6 planks to use as the bottom skids, and then some 4x4 posts as the uprights. And it shouldn't be too hard to find if you just built a deck. You're going to have some 2-foot scraps of 4x4 posts, and those work perfect for the uprights. Also left over, we have from cutting stair stringers, we have these convenient little triangles cut out of 2x10s we're going to use for gussets on the uprights. On the 4-foot, the 48-inch diameter water wheel, we start by taking the pieces we've selected to use for uprights and cut them at about 24 inches, 23.5, 24 inches. Once you've cut your 2-foot upright pieces, take what you're going to use as the skids, and these are a little under 4 feet long, but it doesn't matter. Just about the same length as the diameter of the water wheel. And mark the center of your skids and draw a line in the center line. You mark your layout and just get the post ready to be flush with one side and centered in the other direction. Triangular gusset pieces are square cut, and that's all you're going to need to hold the entire assembly perpendicular. You just lay it all down on a flat surface with the vertical in the middle, and then tack it together with a nail gun. Once you've tacked the assembly together with gun nails, you can pre-drill into the bottom. Once you've pre-drilled through the bottom of the skid and into the assembly like that, just run some deck screws in. Put at least a couple in the post and then one in the bottom of each gusset. You've got the pair of uprights built with the skids, and you can see with the thickness of the skid they'll be plenty tall enough to support the water wheel. Now if you constructed the water wheel with the 2x6 width in here in between for the buckets, then with the skids and everything and allowing for clearance, you need about a 22-inch cross tie piece on the front and the back. And once you got a suitable cross tie piece, you can just kind of square up the corners and tack it with a nail gun. Now, if you don't have wheel bearings or real pillow block bearings or something to use, some 3/4 inch, or excuse me, 1-inch EMT 2-hole clamps will work as bearing saddles. The setup right here with the EMT straps might be pretty cheesy, but it will work in a pinch as a bearing. Don't really need deck screws for this part. You could use, you know, just a coated 1.5 or 2-inch screw and just snug this down. So I blocked up the wheel to mount it in the stand and just put a couple of screws temporarily until these are perfectly, you know, parallel and straight. And noticed right away that it's definitely out of balance, because as soon as, in other words, one side of the wheel is heavier than the other because it's kind of moving on its own. So if you get a good good bearing in it, the heaviest part's going to gravitate to the bottom and stop there, and then you'll know where to add and subtract weight from the wheel in order to make it a little bit better balanced. So in order to test it out, I just rigged this temporary PVC pipe right about the center of the wheel with you know, a garden hose connector on the bottom and a valve to turn it on and off, and we'll try it out. Turn on the hose a little bit. It starts filling up the top box, and there she goes. Definitely heavier on one side as it picks up speed and then slows down again. But that's okay. For a decorative water wheel, there's certainly nothing wrong with that. Don't want it to just go super fast anyway. So there you have it. And then you build a flue that comes in this way out of wood and dumps the water so you don't have this ugly visible pipe. And now we have it mocked up approximately where it's going to go, because what better way to loosen the ground underneath it where we need to dig the fake river and stream and pond than to let it get all wet. Put a little bit of grease on the quote-unquote bearings, and seems to be going pretty good with a minimal amount of water. We have to build an authentic looking flume to feed the water wheel, so use an oak liner out of a old fluorescent light fixture housing from a, you know, outdated kitchen, and then lined it with junky leftover wood, redwood from the deck. And here we have a completed water wheel with pond and recirculating pond pump ready for decorating. Now, instead of a powerful pond pump, we just used a old swamp cooler pump with a very low volume of water circulating. It keeps it going at just a moderate speed, moderate to slow speed. Plus, a cooler pump is cheaper and easier to replace anyway. The cooler pump is this hidden vinyl tubing that goes up under the wheel, up the side of the stand with some old copper condensate pipe and into the flume. It's very unlikely when the water wheel's done it's going to be perfectly balanced and turn without stopping or slowing down, but that is correctable. You find the lightest part, or the side that wants to gravitate towards the top, which would indicate the lightest part of the water wheel. And you take one of these, I use steel shims, and put it right down in the water bucket, and attach it with a screw and a washer to add some weight to one side. There it is right there. There's the added counterweight in one of the water buckets. You use just about anything. I wouldn't use lead fishing weights, just so that you don't contaminate your pond with lead. My little bedded bearing is just water pipe and a PMT 2-hole strap. This is what it looks like after running for a couple weeks with just a bed of grease. And it seems to work just fine. I've seen people use sealed bearings, but really not necessary, and this has the advantage of just being able to lift the water wheel out of the stand to work on it.